I was thinking about the best way to sort of tell this story, and generally, a lot of what I've been motivated lately is how do we take advantage of a lot of the computational power out there, the sensor data, the GIS land use data, in order to help folks out. So I was originally thinking about telling this story in Asheville that got hit recently by major hurricane, major floods. But then I was thinking that sort of changing it up right now, do a little bit of a variable for how I started to go down this path most recently. I was down I'm actually here now in Florida when Hurricane Ian came and major damage around Port Charlotte area. And one of the things that was coming into my mind was, I'm a hydrologist. I know the modeling. I'm well aware of all of the data sources. But how exactly could this end up turning into something meaningful for somebody? And also, is this the type of work that I could be able to deliver answers for people very quickly, very rapidly as the storm develops? And where are we at now with the modeling and the data in order to actually start turning into something to help folks? So that was what started to take me down this, trying to unwrap this modeling towards actually trying to figure out what's going on. So let me first start with a little bit of a demo for what came out of this. And this was from Hurricane Ian. And then I'll move into how this has evolved looking at Hurricane Helene in Asheville. So I built a model for Fort Myers Beach. And we can go look at this. This is a web app that helps visualization of the open source swim engine. This is from CHI. And there was a presentation that I gave up in Canada on this method. And I'll give the sort of the short and sweet version of this to set the tone for how things have evolved over time. So this was a model that was built in order to try to replicate the surge that hit Fort Myers Beach. And there's some nice videos in here to sort of help set the tone as to what the scale of this damage was. So let's get a nice little YouTube video loaded up here. So if you remember on the news, this was a catastrophic level of damage that hit Fort Myers Beach. I'm in Florida now, and I haven't gone to check out what it looks like there, but it's still certainly in a very bad shape. I did make it to the north side of Charlotte Harbor right after the storm because we had some damage up in Sarasota. I was able to help out my friends putting tarps on roofs in Port Charlotte area, and we'd see the military helicopters flying in and out of this area. You learn a lot about the real meaning of your work when you're a modeler. You're typically sitting inside of a computer for most of your working day, but the ultimate goal of what you're trying to do is to help out the public, as a civil engineer does. Is your ultimate goal is to try to improve resiliency in terms of the infrastructure and also protect human life. And that just was so striking to me, is what could be done to try to look at this, to explore this topic a lot more. So I really started to see where are we at right now? Where are we at with the state of the art of technology? And I ended up building this model. And one of the things that was quite useful was on this pier, in worse shape now, but on this pier, it was a USGS sensor. And USGS is a blessing in the United States for the amount and the quality of the data that they are continuously collecting. And in this particular storm, they had the full water level sensor data throughout the entirety of this storm, and the amount of surge that they were getting upwards, I think this is on the order of 15 feet of tidal surge. So I was able to take that data and then plug that into my hydraulic model in order to replicate what was going on here. So this is software called PC Swim. It uses the open source Swim engine, so free and open source from the EPA. The first thing that I need when developing—
Scott, really quick. Yep. Sorry. So just for folks that are maybe a little bit less inclined, so the PC Swim or the Swim engine is an open source model that is made available through the EPA.
Yes. So the EPA engine has a long and proud history. It's an open source engine with a free and open source API. The user interface from the free version from the EPA leaves a lot to be desired. So other folks have created wrappers around that free engine in order to make it more user friendly.
And the one that you recommend is PC Swim.
This is the one that I recommend, but it's worth stating that I have a conflict of interest of if I recommend them and a sale is made, then I'll receive a commission. But it's not to say that there's not other options for folks out there, depending on what's best for their needs.
Yeah, cool.
So this is the basis of a modern 2D hydraulic engine, which is called a DEM, a digital elevation model or map, where the very good folks all around the US, and this data is free and widely available. It's another thing that we are super blessed to have in the United States, is high quality, easily accessible topography data. And this gives me the elevation. In this case, every 3-foot resolution, I have a elevation point. So I'm also able to bring in buildings layer. That's another thing that's very easy to bring into these models. And effectively what I do is I sample all around the model and I try to figure out, I need to convert that high resolution DEM into a more simplified hydraulic model for me to be able to create the simulation. Sort of move forward and take a look at what this actually ends up looking like. Not to go too much into all of the nerdy modeling details, but generally speaking, I can take that USGS tide data and I can plug that in as a boundary condition into my model in order to create a real life simulation of what's going on at that tidal condition, thanks to the great folks of USGS. And I'll look at this in a 2D simulation where now I can watch the wave coming in during the storm. Just a little demo of the cross section of the shore, watching that wave come in. But one of the things that can become a lot more convincing, especially when you're going in front of a public audience, is to have this sort of striking 3D visualization tool where we can actually replicate and watch the storm over time rolling in. And I'll let it'll take a little bit of time as we ramp up. We can see at the bottom here how I'm stepping every 10 seconds into the future. And we're moving through time, and we can watch these waves move in. Maybe this is a time to say that this was a model developed with the purpose of replicating the storm surge of Ian on this community. It's once we can build faith in this model as it was for Hurricane Ian, then you can start saying, okay, that was a 15-foot. Like, how would it have done in a 10-foot? How would it have done in a 5-foot? And we can start creating different levels of risk relative to the surge amount. We can then start saying, well, what if there was a bigger dune here? How tall of a dune would we need to have? We can see the little bit of a inundation of the beach here already helping. as the storm surge ramps up. But in this case, it's just still not enough. This was a major event, and we're able to create risk profiles over time, and we can see the color changing of the buildings during the simulation as to how much flood inundation are they going to expect, and to be able to use this as I'm just imagining you could go in front of a public audience and start talking about the importance of protecting the dune, because the dune could get you up to 12 feet, or it's worth it to spend this amount of money on your beach restoration project. Is it going to get you past a 15-foot surge? Like, probably it becomes a little bit intense then. So then you can also start talking to folks that, like, are you sure you want to build a house right next to this high risk area? There was a very striking video that made the news and was a bit of a viral event. Let's see if I load up this video. So I tried to actually put myself in the perspective of this. This house here, I'll skip ahead on this. There's actually people inside of this house during the storm, and there was a camera right on the light post, and it was able to capture all of the moments of all this going on. Luckily and very fortunately, the people that were in that house ended up surviving, and the gentleman Olson, who is credited on this video, was able to take a lot of the money that he gained through spreading this around news channels and things like that, and actually help them rebuild their life, which was a really beautiful part of this story. Move ahead a little here. USGS, after major events like this, they'll send people out in order to survey the damage, and they collect a lot of data, and they have a nice website and nice portal that actually collects a lot of this information. So they'll go around and they'll look for things like a high water mark. Where was the debris? So like in this case, he's in a public bathroom stall, and he's pointing to a line. He's saying this was the high water mark here, as an example. I was able to take that data and pin the different locations of points of high interest. So this one photo here, I usually like pulling it up because I'll ask people, this is a door frame coming into a house. Like how tall is this door frame? They're pointing a black line there. Like, how high do you think that high water mark was at that point? Maybe I can pick on you, Eric.
Yeah, probably 7 feet.
Yeah, that sounds about right to me. I never actually looked it up to see what the height is, but it sort of sounds about right. So I have a point there in my model, and I can actually look at what my model was saying that the depth was there at the peak of the storm. And my model point there is saying that, yeah, it's like, that's about what I think a door frame is, about that 7 foot. So this is starting to help me become convinced that this model has some validity. This would be a sort of a validation process.
So Scott, that's actually looking at the original USGS storm surge data. The model is then recreating the scenario in that specific location. I mean, or is it like how detailed is the simulation with respect to the locations of it? Is it actually looking at different data, like, the winds or the currents or other things to try and show, oh, maybe in this area it was kind of a higher surge than at that pier, for example, or?
I'm taking the data that's at the pier and I'm applying it all
Hmm.
along the coastline at the beach.
Yep.
This is now a point that's
Okay.
inland, and it's just
From
this
there.
is this is what the model is saying the depth at that
Okay.
inland point would be, and I'm
Which was then
comparing
verified by
this
the
then to the
USGS
photo.
picture. Yeah.
Exactly.
Cool.
That's exactly
That's
what it is.
powerful. Yeah, it's very powerful.
Let's see if that's about what I had. Oh, I've also applied this to other places. Like here's a model of Cape May, where you can simplify this process. You can say, hey, what does 8 foot look like? What does 9 foot look like? What does 10 foot look like? And that's the type of thing then you can use in order to figure out, let's say I want to buy a house, or let's say I want to give somebody insurance, or let's just say I'm trying to figure out if there's a risk for my critical infrastructure that's situated somewhere in this risk zone. It would be good
Hmm.
to have an understanding of where these inundation points are and when do I need to be concerned. Is this something that I can manage? And is this something that I can engineer around? Is this something that my family or my team needs to be aware of? These are all questions that can start to be explored. And I think in a lot of ways, having a visualization technique like this helps make it a lot more real for folks. So that was how I began looking into these sort of rapid developments, low budget. In fact, there was no budget for this. This was just trying to figure out what was possible. Then I started to think, okay, how can this be expanded to other areas? One of the things that was, close this out, one of the things that was quite striking to me, especially coming back here again, and then there was Hurricane Helene that hit Florida, and then Hurricane Milton. I was actually in the eye of the storm for Hurricane Milton. One of the things that I remember being quite striking when I was talking with my mom, and she was rightfully worried about what could happen. There's a, let's see if this website will load. My mom was worried about, is this going to flood when Hurricane Milton comes in? And I was able to tell my mom, it's going to be okay. We're in zone E. So people in Florida, if you ever know anyone in Florida, they all know their zone. What's your evacuation zone? So there's some folks that live in A, and these are the people in the barrier islands, and this is always very scary when there's a storm coming in, and folks will leave and they'll go more inland, and there's able to be this really nice publicly available data where you can, you can figure out what your zone is. And I thought it was such a nice way to help people understand risk and then make it much more real for them with actually being able to put in your address and know what is my risk of a flood. Is this related to wind? No, the wind's going to be a separate issue, but this is an inundation type of curve. One of the things as I started to, I was concerned about Helene and things like that. My friend was or is up in Asheville, and one of the ways that I try to get my own head around what the weather is going to do is I go to this very nice website from USGS, and they're a great thing where, one, right off the bat, they have the storm sensor locations and gauge data for many points all around the US. It's a really comprehensive database of data with a nice user interface on the web. But outside of that, I use this for looking at weather conditions. So if there's a hurricane going on, there'll be a special alert here where you can see the path of the hurricane, like you might see on the news where they keep showing you what the projected path and the cone of uncertainty type of thing. But just being able to look at the radar. where's the amount of anticipated rain going to occur, and I can turn this on a loop and kind of turn it into that local on the Yates weather channel type of thing. If I redid this website, I'd have a little smooth jazz button I could turn on and off. One of the really nice things for this is I can look at, maybe I'm curious to see what happened in the last day, for an example. So right now I know that it's not looking good for a lot of these folks here. They're in a state of hands on deck. What does that exactly mean? I can go to my legend and I can see this is saying that they're getting 9 inches in places. So this is a major event happening around here right now, and a very major event happening around here. We'll probably check the news and see what's going on. We can also look at things like what's going to happen in the future. So maybe I want to look at one day in the future. What am I looking at? If I don't know, maybe I'm planning a drive with my family, or maybe I'm planning to ship some product from point A to point B. I might want to be able to know what my forecast is looking like, not just where I'm going or where I'm starting, but what's in between there. I might want to be interested. Let's just say I know the storm's coming through here. I've heard it all over the news, but I'm interested to figure out which part in this band am I looking at? In this big lake here, like the folks in this area should be definitely concerned about what's going on there right now. And to be able to have a projection looking into the future about these things gives people a bit of a heads up. I did this for my friend up in Asheville, and I called him and I said, "Hey, you're about to get majorly hit. Like, are people talking about it?" And he said, "The only people that I've heard talk about it are my meteorological friends." I'm like, this is concerning. I even told him, like, "Hey, like, maybe you can go out there, do a little bit of a survey for me, like when this is going on." And he sends me a video 2 days before, and it was like a 2-inch event, and that was something where I was like, "Uh-oh, you're telling me that you just got 2 inches and everything's wet, and you're getting like minor, small amounts of flooding right now, and then you're about to get 10 inches of rainfall." So that's unfortunately exactly what happened. They got slammed. And I wanted to try to see, okay, can these approaches be replicated in other areas? Is this the type of thing that we can try to, for example, create a sense of evacuation zones, create the level of thinking that folks in Florida, the way that they think about storms, the way that they understand what their zone is, the way that when there's a major storm coming and people take it very seriously. Can we create that type of consciousness in other places in the United States? One of the ways in which I started to explore it, the Army Corps of Engineers came out with a much more easy to use version of the HECRAS engine called HECRAS 2025. It is in an alpha release. It's not for official use, but it's really quite fun for exploring what's possible to do, and a glimpse into the future of how much easier it's going to be in order to achieve the level of sophistication of floodplain mapping. So here is Asheville. I'm going to zoom out and show you where we're at. In the Appalachian Mountains of North Carolina. For folks who may not know where Asheville is, it's a cool town. It's an artsy town. It's a fun tourist town. They like drinking beer there. It's fun. It's a good spot to be. People do their parties and bachelor parties and stuff here. Similarly to how I was able to get the DEM for Fort Myers Beach, it's very easy to get these DEMs for anywhere in the U.S. and it's maybe a lot nicer to see the colors like this to appreciate what's going on. But the concept of something like a floodplain becomes really quite obvious on this color scheme. You can see that this lighter greenish blue is the floodplain, and then the mountains are the ones that drain into them. So I was able to take similar types of USGS data, they have gauge stations all over the place, and be able to try to replicate this storm. So I'm able to create the flood, and I'm able to look at where the inundation is going to occur. And if I turn off this terrain and look at it more like a satellite, we can start looking at some very striking things, like along the River Arts District. There's a lot of industrial type of activity and a lot of warehouses and things like this. And having surveyed the area afterwards, the amount of debris, like there's PVC pipes like in the tops of trees along this area of just all this, I mean, effectively becomes junk. Everything that was here is now junk, and it's all in the river and it's all in the watershed. And where was the alarm? Where was the amount of preparation? I joke with the people up north that if we get a warning of 2 inches of snow, you're going to get a line for people getting bread and milk in the grocery store. The amount of unpreparedness for this type of thing, given the amount of information that is out there, to me is a major wake-up call that all of this information, all of these models that we're doing, is not being put to good enough use. That this should have been known. In fact, it was known. It's just that people didn't respond accordingly as to avoid this level of damage. To go back to the other point about different types of zones. In an area like this, the type of zone that people are going to be aware of would be the FEMA floodplain. And the storm that hit and the inundation that they had basically was the 100-year FEMA floodplain. It was almost exactly the 100-year FEMA floodplain. So that alone should be a major wake up to people that, hey, we're getting the 100-year FEMA floodplain is going to happen. But there's something that's really quite nice about the Florida evacuation zones, that because there's different levels of intensity, if you're in an area like Asheville, you may not want to, if you're the city manager, you may not want to create a level of panic where if you tell people that there's a major storm coming on and then everybody decides they're going to get on the road, they're going to get on the highway, they don't know when to leave, and there was highway level collapse here. So let's look at something like this. Asheville interstate collapse. Maybe we can see like an image of what this looks like. Imagine if you're creating a sense of mass panic that this is about to happen, and then everybody's on the highway trying to leave, and then this happens. You've now taken a bad situation and you've made it even worse. So to be able to have the ability to clue people in as to who needs to be concerned, to go back to the example with my mom being concerned about the flooding in Florida, my mom might have been one of the people to hit the road because she thinks that it's going to be a flooding disaster. Mom, we're in zone E. Okay, I don't have to be one of those people to hit the road now. Let's keep the roads open for the people that are in zone A. This becomes very meaningful. And I wonder if a lot of the city managers decided to not raise so much of an alarm because they didn't want to create such panic. But I'm sure the case studies on that will come out over time. To go back to this, it was actually able to come down afterwards and survey some of the damage. So I put together a little YouTube video that shows this. So for one, going over and looking at one location, and again, a form of validation. This was Biltmore Village. It's all over the news, if folks that were paying attention. So very popular tourist area. Biltmore Estate is close by. And there's a picture of the Wendy's. So comparing the location of where it shows it in the model versus what was the drone imagery at the time of some of the higher peaks. And then I actually went there on foot. This was I think 3 months after. So there's the drive-through of the Wendy's, the only The only thing left is the ordering booth, and like pretty surreal to walk through this type of location. This is one of the contributing creeks. You weren't even allowed to drive on the other side of the road, and keep in mind 3 months after. So this is 3 months after, and there's still a truck in the creek. The folks that have a lot of their livelihoods, their businesses, this, we completely destroyed it. It becomes a question of where do you move from here to a point, and you could move through this video maybe a little bit faster to show you, sort of go into one of these other contributing areas. My friend was out of drinking water for months. He was out of even any water at all. People were going down to the river to collect buckets of water in order to be able to flush their toilets. I mean, this is a major disaster. Just like USGS finds high water marks, you can also see the inundation on the building line. Shows some of these effect of a lot of the local restaurants around the area. It's pretty sad. It creates a little bit of a traumatic effect for the community too. If any of you have ever made it into these areas, certainly helps frame everything. Maybe I could go down to the French Broad River. My friend's mom had her studio in the River Arts District, so this was her studio actually right there. That's her studio, top floor, and you can see the high water mark down along this building. And they were able to, after a lot of things became a little bit more calm, she was able to go in there and collect what was left of her art studio. It's pretty striking, especially when you think about how many months this was. They will be recovering from this for quite a while. One of the things that I was able to do, maybe to go back to this theme of using data, and especially my favorite USGS, they have this nice gauge there, and they were able to show, they can look at all the different elevations and many different time steps and things like that, but they have this nice graph where they look at the amount of stage versus discharge. So what's the river stage at the gauge versus how much is it flowing? And this is useful for a number of different analyses, but what's interesting about this is they've actually plotted the peak for each year, going back far into time. So you can see the vast majority of them are at below 15 feet, but there's two that are above 23, the major outliers up here. So there's a storm at 1916, and there's crazy photos online. Actually, even back in 1916, we're taking photos of how impressive this storm was. And then here is Helene. So now we're beating even that. So we're talking 10 feet above a previous event. And go to my model. I know where that location is. It's right here is where the gauge is, and I can sort of crank up the juice on my model, and I can see that gauge location. I'm right in between 24 and 25 feet. I don't know exactly where the gauge is, but I know it's around here somewhere. And I'm able to come up with the same answer that gauge had. And the amount of, what was the budget on this project? Nothing. This was something I was able to come up with in an evening, trying to figure out and untangle this web of how can we pull all of these pieces together and to create something that you don't have to go out and have a major bid with a engineering company and come up with a model and then have a big report and make it like take forever. We're at a point right now where we can make these things much faster and much cheaper and much more accurately than we've ever been able to do before. And how exactly are we going to start using this is still part of the question that I'm trying to answer. And how are we going to make this meaningful towards people to help protect lives and property?
So Scott, a question for you on that. So up until this point, this would be the type of exercise that would require a municipality, say the city of Asheville, to engage with an engineering firm to run these types of scenarios. And now you're saying that this is all just kind of publicly available data, and any municipality would be able to take kind of some of these elements, put them together in some of these open source models, and actually run these simulations, or even potentially use these simulations as a means of kind of planning and preparation if a storm is coming, right? Based off of the weather forecast. Is that?
Absolutely. I think that there's a lot of solving this problem is letting the good word know, teach people what they have, just show people what they currently have, what they currently can do, and to help start a conversation of what does this exactly mean, because it's going to mean something different just to everybody. I mean, if you're the city manager,
Sure.
it means something different for you. If you're running the reservoir, it means something different for you. If you're running like a water utility or you have some sort of critical infrastructure, it means something different for you. If you're the fire department, it means something different for you. If you own a business, if you're selling insurance, I mean, this information can mean something different to different types of people. So to be able to just bring a level of education and awareness about what is there, I think is one of the first efforts, and certainly appreciate the Tech Talks opportunity to have a platform to do so.
And what do you feel, or in your kind of experience, what's the level of engagement or the level of understanding that a typical municipality or city would have with something like this?
I think that folks are aware with it. I think they're well aware of it. I think that a lot of times, especially, one of the other things that's very important for the type of work that I'm interested in is, if you're going to go to a big city, they're going to be well funded. They're going to have folks helping them out. But you start to go to more rural types of communities, and they could have one county manager with two folks helping them out for emergency response. Now we're talking about an underfunded area with limited human resources, and they need to figure out how they can make the best of it. So that becomes another type of question. Like, even though they do have access to be able to, maybe build these things out, having a conversation, I think, with them is also part of the future level of education that I need to do for myself, is translating this into something that is the lowest barrier of entry to get involved in. What can you do today? So that's why I like demoing these USGS tools. Like, this is free today. Let me just show you how to use it. And then if you start engaging in it and you start figuring out that this was useful and valuable to you, then there's sort of the next level, which is you could start having a little bit better understanding of these types of mapping. There is actually one very useful tool that NOAA is working on right now. Gauge right here. This is the same gauge, but now on the NOAA website. If I click this gauge, they actually show a forecasted projected depth. So you can look at what was observed, and you can look at what's forecasted. So you don't have to. This would be in the past, people would have to pay a lot of money for a real-time flood forecasting model. But so this is all immediately is very useful as to say, what is the depth here? But if somebody starts finding value in this, or they think that this is really good, let's say it's going to go up to 15 feet, action level 6.5 minor. They have little codes here to tell you in general. But what if I'm somebody that's like a little bit more. There's a New Belgian brewery right around here. I think this might be it. Like New Belgium might want to know, like they might go ask a guy like me or be like, hey, could you just tell me what my elevation is? Or they could just go pull up a DEM and find out generally what their elevation is relative to the water level so that they can actually then be able to interpret what that gauge means for them. That's probably a good spot to take a pause in the story and open up for questions.
What questions do folks have for Scott at this point?
I think people can open up their mics, or there's a chat. I guess we probably should have mentioned there's a little chat window.
So as maybe folks kind of turn off their mute, I'll start with a question. So could you continue on that thread that you were just talking about? So the idea of, because none of these data sets are actually connected at this point, right? Like there is an effort, or there is work that needs to go into kind of bringing these things together, that we're not seeing between NOAA and the USGS and maybe some of these other sources. Is that true, or kind of what is the kind of the current state of these? Are these, is it all just kind of being done independently, or is there kind of a broader coordinated effort with this type of thing?
I think that there is. I'm not exactly sure. I mean, this NOAA website is pulling the information from USGS. Oh, it looks like flood inundation maps here for active events. So I actually, let's see what this is. It's the first time I saw it. Let's see if they have it. Looks like they might be building it out. Maybe we can go find this Kentucky area. This is so here we go. So here's one of the areas.
Oh, interesting.
So they're projecting extreme major. We're getting up to very catastrophic. They're projecting catastrophic flooding. Yeah, very bad. In terms of, if there's actually a map, I don't see a flood inundation maps for active events. It looks like they're.
But I think that's it, right?
Oh, here it is. They are showing inundation. Yes, they're actually showing. They're actually creating a live inundation map for this area now. This is really cool. This is the first time I've seen this. It looks like,
to actually showing kind of where the inundation is occurring across the event in real time.
It looks like that's what they're doing, or this might be projected, but that appears to be what they're doing. Yes.
Wow.
But where is this all going? I think that this is something like right now. I'm learning that I didn't realize they got this sophisticated. This is actually quite. I wonder if this came out today. But I think, to go back to this idea of education and having conversations with people, it's that, what does this actually mean? Like, how do people actually take this and change it into a decision? So I know this is going to happen, but what do I do based upon this? Do I just hit the road, or do I have it depends on who you are. So if you could be an asset owner, you could be a utility manager. Like you might want to have a plan depending on, am I in yellow mode, orange mode, red mode, or purple mode? Have some sort of idea what that means, and to tie in what this data is telling you as to decide how you're going to act. I think there might be something, as I'm kind of thinking through it now, where in school or in your house you sort of go through the motions of a fire drill, where you kind of get used to what the plan is. And I mean, that certainly could be a conversation that people could start to have. What is the plan?
Scott, we have a question here from Michael. How did you account boundary conditions, initial conditions in your flood model you showed? Interested to replicate such effort for storm events for local flooding.
So there's a number of different ways that you could do it. You could do it based upon either a steady state flow model or you could do an unsteady state flow model. So if you were trying to use historic gauge data, then you would go to something like the National Water Dashboard. Let's see if this loads up. Let's pick, like, I guess we'll go to our 4 ends in Kentucky. So you could look at historic data and then you would take in this flow rate and you would turn that into a time series, and then that would become what your boundary condition is upstream. That would be your upstream flow. The other way that you could do it is if you were more interested in a design storm, is you could go over to something like StreamStats. And let's say I was interested to go to a spot over here. Maybe I'm trying to do something like figure out the flows that are going to go to this town here, or maybe I want to design like a culvert or something or model that out. You can go to StreamStats, you can go to a point, and you can delineate. This is an example of how very fortunate we are to be in the US and have such good tools. If you don't have access to a tool like this, you can do a very similar thing in QGIS or ArcGIS. And if that's something you need help with outside of these nice user tools, send me a message on LinkedIn or my email, and I'll show you how to do it in the free QGIS. But this will delineate basin. Looks like that failed for whatever reason, so we'll pick another point. Let's pick it here. Sometimes it's a little sensitive. You have to be very particular for how you pick your point. Delineate. Just refresh the page. Try it again. We'll do this. You have to zoom in enough, and then eventually the stream will go, and you have to pick the spot right on that blue line. Hopefully this one works.
It is pretty incredible the resources that are publicly available like this from different agencies.
Yes, and I've tried to do this type of stuff in other countries, and it makes me proud to be an American to have such great tools. Okay, so I picked the point. It finds for me the amount of area that contributes to that point. So then I can either download that as a shape file, and then that'll let me pull in my QGIS for other types of analysis. But in this case, I'm interested in order to figure out what different design flows are to answer your original question about how would I define what an upstream boundary condition is. You could look at historic data, or another way that you could do it is you could use something like StreamStats in order to look at the return period flows. It's like, what's my two-year flow? So let's go look at the report. So 50% flood, this would be the 2-year storm. I can get my 10% flood. This would be the 10-year flood. And here's our flow rates that I could use as my upstream boundary conditions in order to help send a plug of water down in order to help look at inundation or design a hydraulic feature. StreamStats is the basis of a lot of design work, is these sort of return period floods.
And Scott, how would you be able to take like a weather forecast and translate that into something like this?
So that is an interesting question. You need to be able to come up with some way to translate, either the weather forecast or radar into some sort of that the weather radar will give me an idea of what the rainfall amount is going to be. That what I was looking at is a return period for flow. So there's a number of different ways to do it. One, what I think is probably one of the simplest ways, this is something that I'm exploring now, is how to translate this. Like, how do I translate that bit of radar rainfall into something like a flow? So this one particular website does something interesting as an example, where I could say, what is the rainfall forecast in the next day? So maybe I want to go over here. It's maybe a little sad over there. Maybe we'll go over here. And I could go to my legend and I could see how much rainfall there is. Maybe I want to go to these source. That's not the right one. Try this one. So I can actually pull in that data layer is something that I can now pull into my whatever sort of other program I'm doing to analyze things. So if I wanted the JSON file of that, this layer will pull it up in whatever application I have. I now have an idea that in the next day I'm going to get this amount of rainfall. I need to come up with some relationship between that amount of rainfall in this area relates to this amount of runoff. And there's, depending on how you do that, depends on the level of sophistication that you want. But generally speaking, it's you have to come up with a relationship between rainfall and runoff, and then it's pick your hydrologic method at that point.
Which then can be applied to those models that you've showed us before, right? With kind of the inundation maps and helping people make practical decisions about what might be happening or what they might need to do.
One of the things I tend to warn about is it's easy to go down a rabbit hole of tons of sophistication, of complexity in the model. If you keep there's an analogy in engineering where they show a dartboard and they show the difference between accuracy and precision. And a precision is when you can hit the same spot over and over again, and accuracy if you're sort of clustering around the bullseye. But in addressing these questions, it's important to answer the question right from the get-go is, what am I even aiming at? What is the question that I'm trying to do? And what are the implications of answering that question? So if you frame the question properly up front, then you can greatly reduce the amount of technical back-end calculations that need to be done in order to get you to where you are. You might be able to have a very simple solution to what you need to know without opening up an entire, like a research project's worth of data analysis.
And we have one other question from none other than Raco Ralph, Scott. So with sewer water, there's a combo of sanitary sewer and storm water in CSO. Could a sanitary lift station be used as a data point if you have data collection devices installed? Would the CSO data be worth the time?
Absolutely. In fact, that was what my dissertation was on. It was over looking at Boston. Maybe it would maybe take too long to pull up that data set, not having it loaded, but turn off this. So tons of CSO, or I had data from an interceptor, and that sort of information from, I mean, even if you're in this area is a combined sewer, so that interceptor data I was able to look at dry weather flow patterns, and I was able to look at wet weather flow patterns. And one of the things, if you look at CSO data, is you realize that the wet weather component of combined sewers is by far the greatest part of the flow when it's raining. So having similarly to how it would be important to look at flood inundation, if you're somebody that is managing wastewater treatment, being aware about what that big flow of water is about to come to your wastewater treatment site is very critical information if you're going to try to treat or store or manage that big flow of water. You may have auxiliary storage facilities throughout your network that you need to turn on. You want to be aware of when you need to use your auxiliary storage. You're going to want to be aware of this coming so that you can make sure that you have that storage available. And if you don't, then this might be an all hands on deck sort of situation depending on the severity. So having a bit of a taste for what rainstorm coming in is going to mean for your system at different types of rainfall levels is also a thing, just as the same philosophy we're talking with inundation. Even in a purely sanitary sewer network, sanitary sewers, I've seen data, they look exactly like combined sewer networks. I is a major problem for wastewater sewer operators. The amount of water that could come in during storms in sanitary systems is a major problem in the United States, and the types of resiliency efforts or emergency management strategies that happen during wet weather events is something that both CSO community and sanitary sewer community needs to be very aware of.